So the funding is bullet points. Just make a reflection.
Okay, Jen, please sign the blue sheet. Sorry?
Did you upload your chair
exactly.
slides?
Multiple people talking.
Did you upload your chair slides?
No, I didn't.
No, you didn't.
Well, I'm not sure what chair slide you're talking about. Oh, no, that I downloaded from the IETF.
Oh.
I kind of thought they already had it. But okay, so blue sheets are wandering around, sign in. My co-chair is missing in action. I have no idea what's going on. How many of you have never seen a no wall slide? Okay, so you all know what that says, right?
I've noted it.
Okay, cool. Okay. Let me talk real briefly about the agenda. We have an invited talk, and that's Andrew. He'll be up here in a few moments. What we're doing with the invited talks, we've been doing this for 2 or 3 years. I hope you're familiar with it. But basically trying to target, ideally, people that are deploying IPv6 only. Okay. Ideally, people that are turning off IPv4 or deploying IPv6 only to get their experience. You know, where's the rub? Where does the shoe not fit? And when we can't get that, we've been asking people to simply talk about their IPv6 deployment. Where's the rub? Where's the shoe not fit? So Andrew's going to talk about liquid telecom this morning. Morning. One of those things. Okay.
How can I help? Cool.
So there are, well, actually, so Barbara is taking notes. If somebody could be a Jabber scribe, I would very much appreciate that. Seeing no hands. Okay, so Eric will be a Jabber scribe. Right? So we've got 2 internet drafts that we've been working on in this working group, and we'll see where that goes. And then Eric has a draft that is about to go into working group last call in OPSEC, and asked basically to get feedback, commentary from V6OPS in that context. So we'll give him an opportunity to talk. If we have time, I have 3 other drafts where people have come to the chairs, come to Ron and I, and asked for time. And I haven't seen mailing list discussion about them, in one case in 2 years. And so if we have time, then we'll give them the floor. If they don't have time, I'm sorry, that's the way it's going to be. But we have the slides and we can give them the floor if we need to. That'll be kind of the nature of lightning talk. It'll be a 10-minute talk as opposed to giving them half an hour. Barbara.
Just a comment that the last one, the title is wrong.
Okay.
Multi-deployment twice. Whatever.
Yeah. Huh?
Fair enough.
Okay. You're right. I duplicated that. Okay. I screwed up. It's all my fault. I'll change this. But, yeah. So, at any rate, that's what's going on. Does anybody want to bash the agenda? Do you have changes you would like to make to it? Okay, fine. With that, then Andrew, I'm going to put you to work. Now, you're going to find this one far more useful because that's connected to the wrong computer.
Okay. So, yeah, I think you can hear me here. So firstly, thanks very much for having me. It's actually my first IETF, and it's quite an honor to be here. But yeah, thanks for having us. I'm going to talk a little bit about our V6 deployment today and the challenges that we're facing and some of our solutions to them. I think that a lot of what I've seen in the lists, etc., is focusing on getting V6 to the end user. And we found that the challenges to doing that are actually more related to our backbone, and I'll cover that. But it's a bit of a different perspective from what I've seen on the lists. And yeah, let's jump into it. So who is Liquid? Just to give you a bit of an idea of the scale of the network, we run Africa's largest fiber network, 70,000 kilometers, covering 16 countries. Probably about 12,000 MPLS nodes on the network. It's a large network. And we try and stay at the bleeding edge because it gives us a competitive advantage, particularly with the fact that we're not dealing with a lot of legacy tech, so we get to leapfrog and kind of leave that tech behind, which has its advantages. It also means if you're playing on the bleeding edge, well, sometimes you're going to bleed, and hopefully not too much. So our current V6 deployment highlights, we started our V6 road many years back with one customer in Zambia, and we deployed it across the backbone for that one customer because Liquid has never bought transit in Africa, so we needed to take it all the way through the backbone in order to get it there anyway. We switched our backbone to single topology mode 6 years ago. The motivation was simple. The engineers would forget to put V6 there because, well, it was a second-class citizen, so you enforce single topology. Well, stuff doesn't work if it's not there, and it helps. That really actually had quite a profound effect on our V6 deployment. We then rolled out V6 in Zimbabwe on our GPON network, which, to our knowledge, is still the only major V6 deployment in Zimbabwe, and it was the first country on the Google map to actually kind of show any movement. And it got us to about a 5.93% adoption in the country, which was a nice step forward. It would be a lot higher, but keep in mind that internet in Africa is incredibly mobile-based, and the mobile providers, well, they're not exactly moving very fast in the V6 world in Africa. Our new GPON network in Tanzania, which is only 2 weeks old, built on the same model, and we are hoping that as that grows, we will start to see some movement there. Now, our challenges, because that slide, unfortunately, was where the good news ends. So now we're going to talk about some of the bad news and some of the solutions that we are using to deal with it. So why did things in our V6 deployment stall? Firstly, our customer base is incredibly enterprise-centric, and they are very net-centric, and convincing customers to move from what they know and trust is not easy. We also find that NAT is actively sold in Africa as a security mechanism, and to the point where customers go, but you're taking away my NAT, you're going to de-secure my network, and it's not true, but we are fighting a disinformation campaign on a constant basis on this, and it does not make things easy. Until recently, there's almost no movement on the mobile providers. We are now seeing it with Safaricom in Kenya, the predominant mobile provider, who started to do some V6. The mobile network in Lesotho, and if I get time, I'll tell a funny story about how that one actually came to happen. It was quite a bizarre story. We're also seeing some movement in Gabon, which is Vivendi, but again, it's an international operator. It's not an African-led deployment. What's happening in Gabon? And that is kind of worrying me because I'm not seeing much movement from the African operators themselves. We've also had some major vendor challenges, particularly in the CPE side. If you control all your CPEs, this is easy. You've got one standard CPE. When people are bringing their own CPEs, you've got a problem. And when it comes to GPON, the ONT support that we've seen out there for V6 is horrendous. It is really, really bad. But to talk about our challenges, in Africa, we have a challenge whereby we have to be able to steer our traffic at a moment's notice. Governments in Africa have a habit of doing very strange things and deciding, well, you can't have Facebook, you can't have WhatsApp. And that means that to get to the inland countries, I need to be able to click something and say, divert this traffic from this source to this destination around this country. I cannot spend hours building manual TE tunnels, etc. This is a problem, and the lack of feature parity with MPLS and some of the stuff we're seeing in V4 is actually creating some fairly significant challenges in our deployment of V6 in those countries, because I cannot guarantee the same quality of service because I don't have the same level of control that I get on V4 because of MPLS feature parity. We see some very inconsistent vendor implementations, and this is interesting. There's one particular vendor who, when you order your hardware, if you say I want V6 with it, it costs you nothing. If you forget to say that and you ask them 24 hours later after you've given them the check, you will get an invoice that says it's almost the cost of the router. You do not forget to ask. If you've got legacy equipment from that vendor, you have a problem deploying V6 because it's going to cost you a lot of money. Why not just replace that vendor? Well, there are certain countries in Africa where bringing some vendors is problematic because of export restrictions and other such things. So you are left with certain vendors where they are your only option. I will leave the rest to your imagination. You also have a lack of consistent CPE implementations that cause problems, and it's the reason why we do static V6 on GPON networks, because the whole RAND issues on dynamic V6 caused us absolute nightmares in many, many cases. And then on the translation mechanisms, when we want to go V6 only, which one? There's how many V6 translation mechanisms are there? And well, no, there are a lot of them right now. MAP-E, MAP-T, DS-Lite, 464X-LAT, And the problem with this is the fact that when you've got a multitude of CPEs in play here, who supports what actually becomes a little bit challenging. I'll talk a little bit about that, but let's talk first about the MPLS challenges. We need to be able to steer and engineer traffic. And in the African environment, when you're working across 17 countries where you don't know what's going to happen tomorrow, where you've got a constantly shifting environment, where potentially you can't buy high-capacity circuits, so you have to start balancing traffic because for whatever reason, the provider where you can't build long haul, so you've got to use STM16s in some cases, you've got to have that ability to engineer traffic. All of the engineering tends to be fairly heavily MPLS based, and we found that lack of feature parity has really caused us quite a bit of problems. Do I like the fact that we have to do that? No, but it's a practical reality of working in the environment in which we operate. We need those features. Now, we're using a lot of SR-MPLS. We've been doing that for about a year and a half, and it's worked very well for us in many cases. Unfortunately, when you get to certain countries where you are running the vendors that you have to use there because of the political reasons, you find that they've decided randomly that they're not going to support IPv6 with SR-MPLS at all. It's just not there. And they won't even discuss it with you. They just go, well, you'll use SRv6, but then the other vendors that you're using elsewhere don't support SRv6 yet. And of course, you end up with a problem. We have a rather interesting solution to this problem, though, that I will talk about later that we've been testing. In order to do the end-to-end traffic control and steering, as I said, there are islands of this hardware that doesn't support SR-MPLS, and there's a bit of a solution. There are also some fairly major challenges with regards to BGP-labeled unicast, And keep in mind that we consider LDP6 a stillborn child. LDP6 just never really happened. That means if we're doing MPLS with V6, it is SR, and SR and BGP labeled unicast in the absence of LDP don't always play so nicely together. You get random label insertions and other funny things across all of the vendors. So you have some issues over there. We've largely managed to work around them. Primarily what we see is the fact that it introduces an extra label onto the stack with a random label that it generates. And in low label devices, we've only got 3 labels to work with. This, well, causes problems. So we've had to work around that. On the vendor implementation side, our traffic control and our steering is heavily BGP link state. We use a lot of link state with our controllers. And the implementations from the vendors around BGP link state, it's all there in the RFCs. The TLVs are there, everything. Unfortunately, the V6 TLVs in a lot of the vendors are just, well, missing. They just don't show up. And so that's a problem, but we're working with the vendors on that and saying, please, we need a consistent implementation here, but it does create problems with our entire traffic steering chain. The support for V6 on low-end CPEs is as inconsistent as it comes. I mean, it is a mess out there. You name the CPE, and I mean, I think I've got a cupboard at home of about 50 different CPEs, which we went through testing one by one, and every report is inconsistent. It was quite bad. And so that's created some issues. The other thing is DPI. The DPI support for traffic through V6 is getting better, but it has been extremely patchy. And classification of traffic, again, I don't like DPI. We prefer not to run DPI. Unfortunately, in certain segments of the network, it is a necessity. And so problems with DPI on V6 traffic have caused us some issues. On our translation mechanisms, at the moment, it's looking like we are veering towards DS Lite because it's supported by all our GPON ONTs. It's the one thing that is. And I know that there are a lot of people who are going, but why not map E, why not map T, why not this, why not that? In our testing with what we've got on the network, this is just a practical, it's a practical decision. This is what we see as the most supported in the technology that we have on the network. No religious preference. I don't do religion. I do what works and I can sell to my customers. You know what I mean? But at the moment, we've also still got V4 space. So our preference is still just to dual stack it until we run out of V4 space. We're in the lucky position where we still have V4. Afrinix still has some V4. How long that lasts for, well, we'll wait and see, So we'll dual stack, but we are in no ways putting on a backseat the translation mechanisms in our exploration, and we are actively working on that and testing out the options. There we go. So the solutions that we've got. On the SR-MPLS and steering the traffic, SR-MPLS is our preferred method for solving our MPLS issues. However, most of the MPLS protocols, particularly for L2 circuit extensions, very heavily LDP tied still, Martini, Compeller, even L3 VPN. You can't turn up an L3 VPN with V6 without some form of V4 underlay. Don't ask me why that is, because it should be BGP signaled, but it just is. You need that local V4 address. Now, we see some hope with EVPN and EVPN, VPWS for circuit extensions, etc., because that does just work, and it works on an SR backplane as well. Then on those islands I talked about, so actually it was this week, and I wrote some P4 code to test this. We need to kind of skip over these islands but maintain the end-to-end traffic control. So I might get told I'm completely insane here, but what we've been looking at is using a binding label on the SR stack of labels and steering it to the edge of the network and using that binding label to pop off the binding label and then effectively push a V6 stack onto the packet with a compressed routing header destination option in there, and then using stock standard routing to the other side, pop off the V6 header again, push the traffic back on, and use BGP signaling in between to signal the labels across it, which means that you can skip over the island, which will solve one of our problems. It's one of the more extreme solutions, but it does potentially solve a problem. We also believe that SRv6 is coming. We have quite a number of concerns with standard SRv6 though, and with regards to address overloading, wastage of V6 space, and yes, that is actually a concern when you look at the volumes of it. And so we've kind of got involved in, we know what we need here, so we're working in the Spring Working Group to say, this is our perspective and see where it goes. Our preference is always going to be SR-MPLS, but we know that certain vendors are not going to support V6 on SR-MPLS, so we need to ensure that whatever option does come out of that works for us in the absence of that. Not ideal, but it is what it is. Then on other challenges and solutions, on the link state problems, we're working with the vendors. We've seen some success, but we augment through other data sources if necessary. Not ideal, but functional. On DPI, it's getting a lot better. We've been banging on the vendors' doors for a long time and, like twice a day, fix this, fix this, fix this, and it seems the harassment seems to be working. We've also, because of the inconsistencies in implementation, changed the procurement models that we buy routers under. We now say, here are a list of RFCs that you have to support. If you deviate from this RFC in any paragraph, tell us where, tell us why, and tell us when you're going to fix it. And if you don't comply with it, I reserve the right to return the hardware when I find out about it. It's actually worked quite well. You'd be surprised at how honest vendors come when there's a clause in there that says, I will return the $2 million worth of hardware if you lie to me here. And particularly since we've done it once. So it changed the procurement model and it puts pressure, and it does seem to have worked quite well. You also find that suddenly you get a new code release that fixes the incompatibility, quite particularly on the bigger orders. There we go. So moving down the track, we're busy V6 enabling some consumer networks in Uganda, Rwanda, Zambia, and Kenya. Some of that stuff will start showing up fairly quickly. Some of it is more problematic because of GPON ONTs that aren't working on the vendors we're working with in Tanzania and Zimbabwe, and we've got some issues there, but it's something that's actively being worked on. We've, within the last week, launched a new network in South Sudan, which goes effectively from Kenya to Uganda and up into South Sudan. And obviously there's a lot of traffic steering issues when you start talking South Sudan and Uganda in the middle, because there's some interesting politics there. But we're doing it anyway. And that will be V6 enabled from day one, using all the SR technologies to deal with some of the problems. Our investigation on the translation mechanisms continues, but we've got some room to move because we've still got V4 space. And it's not taking a back seat, but it does take some pressure off us. And then we'll continue working in the Spring Working Group, and hopefully we'll get to the point where we do feel that we've got enough parity to really do what we need to do. We are betting the house on SR to solve a lot of our problems. No denying that. It's just a question of where the SR debates go. It's going to be very interesting to see. And then by policy, we now deploy V6 towards every client on the interface. There's a 64 on the interface and a 48 routed to the interface, and we don't care if you don't use it. We will try and get you to use it, but if you don't, it's there, it's deployed, it's allocated in our systems, and we'll tell you about it, but every client, we're now putting it on there. Sadly, getting them to actually use it is a problem, but we deploy it by default, and there's just no option for it. It hasn't had much of an effect, sadly, because it gets to the edge and, well, the customers don't do anything with it. Then we're launching some fairly major V6 awareness campaigns fairly shortly, and we're using a platform that we've got, 21C Skills Initiatives, which we're trying to use to train people in Africa. And this all consists of training videos, white papers, promotional materials, etc. And we'll continue to try and dispel the myth of security by NAT. We are looking at potentially doing cloud-based firewalling to the DIA customers, etc., to say, you know what, get rid of your NAT. We'll push your V6 through a firewall, and you don't have to pay for it, but we'll do that to protect you against this myth that NAT is protecting you, and we'll still get rid of your NAT and we'll get your V6. So that's one of the initiatives. But that's a little bit about, a quick brief on what we're doing, and hopefully somebody finds that useful. So thanks very much. If anyone's got any questions, just grab me afterwards or
Come to the mic.
Jordi Paulette. I have the feeling, I am not really sure, but I have the feeling that when you mention translation mechanism, you actually want to say transition in general.
Yes,
okay.
Transition mechanism, sorry.
Yeah. That created some confusion at the beginning. One of the points that you mentioned about the CPE support for the transition mechanism, especially for IPv6 only and IPv4 as a service, you may not know, but about 3 months ago, this working group got through RFC 8585, which is probably what you should ask to your vendors for new firmware updates or new equipment or so on. So you have all the choices depending, even if if the customers buy the CPE outside.
Yeah, cool. Thank you. That's actually good. I didn't know that, and it's something to look at. I think there's somebody else hitting the mic there.
Hi, my name is Uma Chundari from Feature. A great presentation. Thank you so much. I have one question regarding in one of the slides you mentioned there are routers where you cannot push more than 3 labels so you see a lot of that equipment, because that's generally we see in cell site routers where the routers are small in backhaul. There you can use Broadcom chips. You cannot put more than 4 labels. It's a general case for you, or how is it?
We see a lot of that, particularly down at the edge, and we see that in some of the aggregation stuff. Where we hit the 3 label limitation and we need to traffic steer, we do that through the controllers using SR and binding labels, and effectively bind a label and switch out the stack at intermediary points to lower the number of labels on the stack at any one point. That works quite well in a completely controller-based environment where you can automate it.
Mm-hmm.
If you are not automating that, though, and you've got that amount of stitching happening, it's a non-starter. You will lose track of it everywhere. You also do have a couple of challenges there with regards to end-to-end path testing, etc. And we had to do some quite interesting stuff on the operational side to do end-to-end SR path testing, where we're injecting packets that have labels that take it to the head end, use a binding label to take that packet through the tunnel and back to the controller, and then measure whether or not the packet's arriving back and packet loss, etc. Because it gets quite interesting testing whether a path is alive once you've injected it with BGP. But that's worked quite well.
Yeah. 3 is really small number. You have VPN label, BGP LU. After that, you have only 1 label, that is LDP. Then you have to replace with binding SID now.
Yes, it does. It gets a little bit interesting.
Thank you.
Certainly. Anything?
Do we have anyone else? Thank you.
Cool. And I'm around all week if anyone has anything else? So, yeah, thanks.
Sure. Okay, Jordy?
That one? You make it full screen or that will work?
All right, yeah. Isn't that what this thing does?
Yeah. Looks
Well,
like.
No, it
No?
doesn't accomplish what you want. You want to be able to see the entire slide.
Oh, it's okay. That's okay, I think.
Okay.
I can move through without going to the middle of the screen.
Okay.
Okay. This document was presented for the first time in the last IETF in Prague. Alejandro, which is the co-author, actually he's online in Argentina. He come to the list with a problem. Hey, I am willing to deploy 464XLAT in my broadband network, but when I do CGN, I can optimize the traffic to the caches, to the CDNs, and so on, but I cannot do that with 464XLAT. So there is any way to find a solution. So we started working on that. That's basically the problem statement. Of course, with CGN, this only works for those CDNs or caches that are able to use the private addresses special for the CGN, right? So it's range 100.64.0.0/10. If they cannot accommodate to that, it's also useless. So this is the typical 464XLAT deployment where you may have the NAT64 and the connection to internet, and then you have the IPv6 internet. If in addition to that, you have CDNs, I don't know if this will work, yeah. If you have connection to CDNs, and just a note here, we started this document thinking in CDNs, but actually we realized that it's useful for any IPv6 enabled service. So if you have CDNs here, oops, that goes too fast. Yeah, wrong button, this one. If you have the CDNs here and you have here an IPv6 enabled device, you take advantage of this flow, right? Of this end-to-end with IPv6. The problem is when you have, for example, a smart TV or a set-top box, which typically is not yet IPv6 enabled, what is going to happen is that even if this device here, the CDN or the cache or whatever, is dual stack, the flow will be through the NAT64. So you are doing an IPv4 to IPv6 and then again to IPv4 translation, which don't make sense. And this is something common in other transition mechanisms. For example, MAP-T is having also the same problem, okay? So in fact, even, again, the original document was thinking in 464XLAT. This is also a solution for MAP-T for this optimization. So what we are trying to do is this one. Because this IPv4 only device will get translated to IPv6 by the CLAT or the NAT46, which is the same. We want that this flow can reach directly the IPv6 side of the dual stack service, okay? Instead of going through the NAT64. That's the idea. So how we do that? Well, this will be the picture of the different scenarios. So we have optimal scenario. We have dual stack devices or IPv6 enabled devices behind the CPE. The suboptimal will be if we use the path through the NAT64, and then what we can do is, again, getting that without the NAT64 translation. So we keep the CLAT translation, the NAT46 translation, up to the destination, which IPv6, okay? Now, we investigated 3 approaches. One of them is equivalent to the CGN that I mentioned before, which is having the CDNs and the caches using the NAT64 addressing space. So if you are able to configure your CDNs with the 64 prefix, that's ugly, but it's the same that we do with carrier NAT, right? So that will be one possibility. Of course, some CDN or cache providers don't like this. They don't want to use their interfaces that 64 addressing space. And it has some complexity because you may be using a network-specific prefix, and of course, this will only work if the CDNs or caches are in the ISP network, but not if they are, for example, in an IX, because the NAT64 prefix is non-routable, okay? So the second approach is let's get the CLAT, which typically is in the CPE together with a DNS proxy, to talk together and guess if the device that is trying to access a dual stack resource or an IPv6 enabled resource is an IPv4 only device or application. If we don't succeed in that guess, nothing happens. We still don't break anything. But if we do a good guess, we are able to have that traffic flow to go end-to-end to the IPv6 address instead of translating twice. So even if we make a failure in the guess, it's still not breaking anything, okay? That has been our primary consideration with the design of this approach. So what we do is a few steps which are detection of supposed IPv4 only devices or applications, detection that the destination is IPv6 enabled. We create explicit address mapping tables for connecting those two sites, the source, the IPv4 only source with the IPv6 enabled destination. And then we use existing routing to forward the IPv6 traffic, okay? And then we have some points based on DNS TTLs to maintain the entries in the explicit address mapping. So one example, let's suppose we have a smart TV looking for www.example.com and it gets an A record. And even if the smart TV, because it's IPv4 only, is not asking for the quad A record, the CPE will do that, okay? So if the CPE can guess that it's getting a query for an A record, it can infer that probably it's an IPv4 only device, because if you get a query first for the A record, most probably it's not a dual stack, okay? Again, if it's a bad guess, we still don't break anything. Then we create this mapping table, okay? Or mapping entry in the explicit address mapping table. And then the NAT64 or CLAT, sorry, the NAT46, that's incorrect. That should be NAT46, or the CLAT is translated to that address. And the CDN, of course, has the quad A address. So it just works, okay? Now, let's suppose there is another device in the same CPE that is asking for a different name. And this was as a consequence of Martin, I don't remember the name, but a Czech guy that was in the last meeting, and he was saying, hey, you are forgetting what we call the reverse proxies. Reverse proxies have a single IPv4 address for multiple IPv6 destinations. So if you just do this part, it's not going to work. So in the last version of our document, we included something else to solve this problem, okay? So the thing is that if we detect that another query is using the same IPv4 address, we need to discard the optimization. So in the case of reverse proxies, we cannot do that, okay? Because otherwise we may break one or the other connection, right? We did a lot of questioning about our procedure to make sure that we are not breaking anything, because the point was, let's make sure that if you deploy IPv6 with this optimization, the CDN will be happy, or the service provider will be happy. We cannot have the risk of breaking anything, okay? Because that means the CDN will disable IPv6 for that customer. We don't want to go through that. So we do a lot of points on that. And then there is a final approach, which is somehow equivalent to the automated approach in the CLAT, talking with the DNS proxy inside the CPE, but in this case is manually configured by the ISP. So the ISP can get the EMT and send it to the CPs, okay? But of course that means configuration by the operator. So we wanted to do it automatic. We believe that from the three approaches, based on routing or the automated one or the manual one from the operator at provisioning, the second one is the best choice. In addition to that, there is an interesting thing here is that today we don't have a solution if there is an IPv4 only device here, like a set-top box, and we have an IPv6 only service. Of course, we could deploy SIG-DC, right? But maybe this can provide an additional solution to that, which is, even if this is IPv6 only connected, if you put an A record, this will work, right? It's ugly, but it works. So this may be a way to, I do really need SIG-DC? Well, not really. I just create an A record even if I don't have this box connected to IPv4, because I am never going to use that, because everything will come by IPv6. Of course, but the idea is that you can have a web page in the ISP saying, sorry, this service is only for IPv6 enabled customers, okay? Because if you don't have IPv4, the rest of the customers will never reach that. So we are not creating any additional problem, right? So that's the thing. Thank you. Questions?
Eric Klein. It's not just about other names that have the same IPv4 address. It's also IPv4 literals, right?
Yeah, it works the same. Yeah, for quick, I didn't mention, but yeah.
No, but like if a web page has an IPv4 literal,
no.
that matches
the thing is,
entry table, you're not going to have a DNS lookup to notice that your EAMT or whatever it is invalid.
But then the EMT was not created. The EMT entry is created only if you have a DNS query.
Right, and my in this scenario, what happens if the EMAT is created because of a DNS entry? And
yes.
Then subsequently, somewhere in a page, there is a string literal.
Okay, if I remember I thought on that. I remember I thought on that.
This was part of why the original NetPT was deprecated. I think
okay.
It's in 4966. There's a bunch of reasons why this stuff was replaced with the NAT64, DNS64, separating them out later. You're sort of reinventing NatPT.
NatPT on top of 464
it relied on observing all of the DNS going by to do all the mapping, and it was separated out into NAT64, DNS64, in part because I think it's 4966 that deprecated NatPT. You're kind of reinventing it.
I need to think on that, but I believe I was considering that case, and it was not against this mechanism, but I need to think on that again.
Eric Vag, I won't comment too much on the feature itself. I got some reservation, to be honest, but the name should be changed indeed, because if ever it works, it's wider than purely system.
Yeah, that's true. We started, as I mentioned before, we started this as only thinking in 464XLAT, and then we realized that it's useful for, in fact, any 4.6 translation, right?
So Warren Kamari, Google, I haven't thought this through, but you said that it doesn't break other stuff. Doesn't this also break DNSSEC? Yes, DNS64 does as well, but this feels like an extra.
Okay, if you are using NAT64 with DNS64, DNSSEC may be broken already.
No, but if you're not using NAT64.
No, we are not using it. Sure. But if you remove the optimization, what will be the result? DNSSEC broken as well. You see the point?
Yes. And we have a comment from the cyberspace.
Yeah.
too many times.
All right, while we wait for him to rejoin the queue. Jared Mach, Akamai, CDN, or at least wearing a CDN hat. I mean, we find our customers pay us to work in all the situations. And I'm concerned about this because this is likely to break the customer experience. They don't want to have their end customers end up at a page that says, I'm sorry, this content is only available if you're on a V6 network. So this seems infeasible. This seems interesting to discuss, but infeasible in practice.
Okay, we had conversations with several CDN providers, including Akamai, and they told us we don't want to use special addresses for IPv6 in the interfaces. So if you find a better solution that having manual configuration of special addresses, it's better for us. That's what we got from you guys.
That would help address at least one slice of the concerns. But I think, generally speaking, our customers pay us for the performance and for a functioning service. And in ways that this would show up in operations, I'm extremely concerned that this would end up causing the customers, the end user experience to be extremely poor, and they would be better off going through a NAT or something else as a result than trying to go and communicate to us, especially when our customers are doing, in some cases, multi-CDN approach. So we have to actually coordinate with them and with everybody else in order to achieve this. And you're seeing some of this play out in the DNS working groups as well, with how to do things like a name, et cetera, with how the domain name holder can actually have stuff show up in multiple different realms. We also have other additional issues that'll come up from DNS tunneling, which I won't get into here. And so, yeah, there's a lot of reasons why this is cool, but it's also more reasons why it's not going to work.
Alejandro, just a second. Alejandro.
Hello. Hello. Do you hear me?
Yeah.
Okay. Hello. How are you doing, Jordi? Thanks for the presentation. Well, this is very interesting work we have working with Jordi. I just wanted to comment some things to add what Jordi said. Of course, this draft is called 44 XLAT optimization, but as you know, in the process we were working on that, we discovered that it helped to other transition mechanisms like MAPT and other. It also achieves not just services within the ISP. It also helps to bring service out of the service provider, right? So, but as Jordi says, I work in a network operator in Argentina, and I really like 44 XLAT. But when I was implementing that, because I was able to get a firmware in a cable modem to support CLAT, I discovered that I won't be able to implement this transition mechanism because many network service provider already have an optimization where we avoid to use the CGN by doing a bypass and let the CDN to deliver directly the traffic to the cable modems without going through the CGN. So if we implement OC4 XLAT as defined in RFC, we will need to deliver again the traffic through the NAT64 to any NAT64 to the final TVs or set-top boxes, which most of them are just in IPv4. That's why I won't be able to recommend to our company to start using 44 slot, because we will need to implement a large scale of NAT64. That was the main issue. And another point, as Jordi said, that we were talking with many content providers of CDNs. For example, Facebook informally said to us that they were interested in any transition mechanism that can avoid definitely a second NAT64 or a CGN, because they obviously they want to get the most transparent connection to the final customer. So most of customers already has a CPE in router mode, right? So if we will add in another NAT device in the middle, they don't like it. For example, Google has officially support for deliver traffic directly without going through CGN. We didn't have any saturation and any congestion, but when we implemented that, we saw that the final traffic was incremented a little bit, but was incremented, and we didn't see any problem in congestion and ports or sessions in CGN. But it showed to us that obviously with a most direct connection without going through the CGN, we finally get a best performance, which confirmed that this could be a right way to optimize the network. So that's what I wanted to share.
Okay, thank you. Andrew?
Yeah, Andrew here. Jordi, I was watching that last section of your presentation, and maybe I'm missing something here, but if you add a fake A record to make this work, that works okay if somebody is behind this. However, if you've got a v4 only client outside, normally when he's browsing and there's no A record, it goes, well, there's no A record, go away. And it does that pretty quickly. If you've got a fake A record there, it's suddenly going to cause some significant degradation as it tries to access that. And if there was a real v4 address there and you were using a real 4 address, well, then it's dual stacked anyway. So the option of using a fake A record on something doesn't fly because it will break people who aren't behind this.
Andrew, I probably misexplained it. This was not the original idea of all this. This is an extra, and we don't know, and I think I have in the draft as question marks. We didn't thought on this originally, but we thought, okay, if some people start deploying IPv6 only services, if they are not reachable by IPv4 only devices, right? They will break. Now, if you have such kind of services in the future, and you do this, you at least solve the problem for set-top boxes and smart TVs that IPv4 only. For the others, will not work. But because it was an IPv6 only service, not intended to be accessible by IPv4 only devices. Okay?
No, what I'm saying, Jordi, is the fact that yes, it won't work, right? But there is a rule that if something's going to fail and it's not going to work, it must fail fast. If it's a fake v4 address, the delay in that failure is going to be far more extended than I do not have an A record, go away.
Unless
that is my concern.
Unless you have a web page, if it's a web page service that says this is not reachable because you are not on IPv6. Again, this is an extra. This probably this need to be in a different ID. So don't consider this as the main thing of this presentation, because probably we are going to split the document in 2 different documents.
Hi, Igor Gashinsky, Yahoo, Verizon Media, Verizon, named du jour today. So if you go back, you essentially are saying that you're going to watch for DNS lookups. Then you're going to look at the V4 answer, do a query against or find the equivalent V6, and then create a mapping. So here's the question. Majority of CDNs out there use CNAME chains in order to do this. So look up against example.com, which will CNAME potential to a different place for V4 versus V6. Now you have another lookup. Which one are you going to try to fake on us? Because we do this for performance reasons, and odds are the 2 mappings are not the same. So how in the world are you actually going to do this in a way that doesn't massively break performance?
Okay, but let's look from the CP device. From the CP, if I do a query to reach Yahoo, I will get to a place, right? If instead of an A query, I do a quad A query, I will go to another place, right?
Yes.
Now what I am saying is, I am telling you, Yahoo, that I am not an IPv4 device, I am an IPv6 device. That should work, because you don't know in advance which kind of device you have in the CP, right? Or behind the CP.
So
there's no way to know,
right,
exactly.
There's no way to know, but
exactly.
What I'm saying is that in the process of doing that, let's say mail.yahoo.com, you tried to go there, and you decided to take my answer for mail.yahoo.com that's New York, and now try to look it up from a different place, because now you're going to do it from a different place. And that different place is going to tell you San Francisco. So now you're going to just assume that New York equals San Francisco in V4 or V6 potentially. And
from the same.
Well,
it's the same, because if I am a real IPv6 device, I will get the same response. And I am going to use the TTLs for the DNS responses.
No, you may or may not get the same response, because the pools for the servers are not necessarily the same, and they're not going to the same VIP, and they're not up at the same time.
You're right. Maybe or maybe not, but this is the same result as if I am a real IPv6 device.
But if you're a real IPv6 device, the content provider is going to be responsible for how long the maintenance lasts, at what point our timeouts kick in. There's 2 different sets of TTLs for V4 versus V6 records very often.
So it's not just the DNS TTLs.
There's a lot of intelligence in there that you ignore.
What we have asked several times in the list is, please, people from CDNs, tell us if this may work or not, and what we can do to improve it. So please go to the list.
I mean, one of the big things is that, our V4 services are there for a reason, and we probably would not want your fake V6 connectivity, because, so one of the big things is that some apps do not support don't support V6, not because you can't connect to them over V6, but because for login requirements or whatever other security tokens, whatever, they're not V6 enabled from a abuse perspective or something else. All of a sudden, you trying to connect and spoof them out from a V4 client that can't actually provide sufficient information over V6 will break things, which will result in most of us blacklisting you, which will break things even more.
Well, what we are trying precisely is to avoid that. So the way we are doing, we believe, is not going to create anything bad for you. That's what we need to double check with your help, guys.
Well, no, the thing is, you're making the decision in the middle without any information on what either side needs, and you're making a lot of assumptions. And you're making the assumption that you could do this in DNS, which, as we saw with NatPT, failed utterly, because there's a lot of protocols out there that use V4 literals. And there's a bunch of other stuff out there, which is why it was deprecated to begin with. This seems like a giant step back.
We've only got a few minutes left in your slot. I need to wrap this up.
Yeah.
So thanks, Igor. Warren, did you have something you wanted to say?
Quick question. So you have the CPE doing the DNS lookup. Something I couldn't figure out from the draft is the CPE supposed to spy on all DNS traffic or only queries which are actually sent to it is it supposed to do this?
Only the queries that are sent to it.
Because like in some countries, it's like 70 or 80% of people just don't use their CPE provided DNS.
Exactly. And that's already mentioned in the document. If you don't use the CPE for the queries, you will not get optimized, but we don't break anything. So that's already in the draft.
Okay, so I think we need to close this up. It's not ready.
Please go to the list, especially, or I am here all the week, especially the people working in CDNs. I think we can probably fix if there is anything broken here. Thank you.
Okay, so this kind of needs to become operationally useful. Now,
Does this work?
so yeah, that's the one you want, I think.
Hello. So I kind of have a problem. Yeah, big one. When users try to connect to V6 only networks, they sometimes coming back to be complaining that, oh, it takes ages for my device to confirm that there is network connectivity. So after looking into it, what we found out is how host joins the network. Or actually, it's almost the same if host configures a new global address. So host sends an RS. Maybe if there is a corresponding option into RS, router might create a neighbor cache for host link local. Doesn't matter actually. Then host gets back an RS, which I forgot to put on this picture, and then it configures global address, default gateway, and it has a neighbor cache entry for default gateway link local address and the corresponding MAC address. So host is basically ready to send traffic. All good. Now host starts sending traffic, and actually address may be still optimistic if a host is using optimistic dot. Host sending an address packets somewhere off link. Router successfully routing them off link, and all looks good. No neighbor cache updates at this stage, right? Then return traffic comes. The first packet appears on the router from outside. Router caches the packet. Look, I have no neighbor cache entry for the address. And it creates incomplete entry and starts all this neighbor discovery process. Meantime, more packets arrive. All those packets get dropped, unfortunately. Then, at some point of time, NA coming back from a host, router neighbor cache entry change state to reachable. That first buffered packet may be delivered to a host, and more traffic eventually appears. Apparently, some applications might be unhappy about all those packets being dropped, because if, for example, they implement incremental, like exponential backoff, it might introduce huge delay. And in general, when I look at this, it basically means we designed neighbor discovery in a way that it intentionally drops packets all the time. There is no way to avoid it. It's like by design, which is kind of sad. No, seriously. So what I'd like to see in ideal world, like spherical network in vacuum, all good, right? So ideally, as soon as a router starts sending packets from a host outside, it would be nice to somehow create a neighbor cache entry, right? So when return traffic arrives, it's all ready. And actually, if it was just two hosts on the same link, it happens. Because neighbor discovery takes care of it. If you send an NS to talk to host will create a neighbor cache entry because it assumes that you want to talk to me, I might need to send some traffic back to you soon. So actually on dual stack networks, we do not notice this because when IPv4 address is configured, host actually announces that. And all neighbors, including routers, get their caches updated. And as a result, because we have happy eyeballs, dual stack networks working very well. So, as I said, the problem is that this would have worked for on-link communication, but it does not work because routers are not supposed to create a neighbor cache entry if they receive an NA. So if we try to do this ARP-like thing for neighbor discovery, it would not work because 4861 explicitly prohibited with a good reasoning, which works for on-link communication. But for routers, it's a completely different use case if you see. Router might need to send traffic back without receiving NS previously. So it looks like the reason is good, but not for routers. So routers should be kind of excluded from that logic. So, as I said, what we're observing packet loss all the time. Delay for applications to start using the network. And as a result, unhappy eyeballs because users are complaining, you turn off V4 and now everything is worse than before. So options, what we can do, we can say nothing. We can look into, can we tweak neighbor discovery? Or we can try to look into advertising addresses from hosts. Or we can just fix hosts and applications. Yeah, there are options of buffer more packets on the routers, but obviously it's not an option because we basically make routers susceptible to neighbor discovery cache attack. Lawrence, you want to comment or you just want me to finish?
No, I think there's something else we can do, which is also a bad idea, but I'll say that later.
Okay. So before talking about solution, I was trying to summarize how the solution should look like. So obviously, it would be really nice to create a stale entry in router neighbor cache for a host if such entry doesn't exist. Obviously, we do not want to override the existing entry to minimize the disruption because, as I said, address might be optimistic. So we do not know if there are any real owner of that address on link. But again, it would be nice if applications could use it for optimistic addresses as well, because it's exactly the case when you want to start using the network as soon as possible. So if a device or application is okay with delays, they probably would not be using optimistic addresses, and they might be okay with like 10-second delay before they could connect. And also, as you might know, in some networks you have more than one router, so it would be nice if traffic leaving the network from one router and return flow goes through another, it still works. So again, nothing working as intended. I don't know, maybe we can say, okay, it's a cosmetic issue, we can wait for 10 seconds every time your host connects to the network with a new address. But as I said, obviously it makes people unhappy, and I think it hurts the deployments. So users get a feeling that V6 only networks do not work as well as dual stack ones. So it's introduced additional resistance. So Pascal made a great suggestions about can we look into registration-based ND, which is used in the other types of the network. Well, it's a kind of, maybe it's a strategic solution. I don't know if by solving this problem we introduce other problems or not, so I think it should be discussed maybe actually in 6man and not here. So I'm not covering this in this slide because I think it should be completely different topic. What we can do tactically, again, coming back to NA logic, it looks like it does make sense for host to do the same thing as we did in V4 and advertise a new address. And for routers should ignore this should, because should means you don't do this unless you have a very good reason. And I believe providing, when I read this justification, router, it doesn't apply to routers. And actually, some vendors, well-known vendors, actually have this already. It's a configurable feature when they could glean from NA packets sent by devices. Yes, I say the good thing is it's actually RFC compliant. We just need to ignore should. And already implemented, so there is actually deployment experience with this. And it works for asymmetric traffic flows. So we have first hop redundancy, all routers will receive NA, all routers will update neighbor cache. Obviously, yeah, it would require some changes to hosts. If host wants to start using network as quick as possible. And obviously, this feature needs to be configurable because probably nobody wants this by default to prevent attacks on neighbor cache exhaustion. And again, every time you do something with ND, as I discovered, you have a slight chance of being affected by smart intermediate Wi-Fi devices, which can do some neighbor discovery tricks, but I don't think we can do much here. Another options I looked at was host might send neighbor solicitation from its global address to a router. It would create stale entry for that host, for that address on the router, because again, it will be like standard neighbor discovery state machine. If you get an NS from you, I probably need to create an entry. However, the main problem here, it would not work for optimistic addresses, because exactly for this reason, to prevent disruption in case of duplicate addresses, hosts are not allowed to send NS with source link layer address option. So this would not work. Another option is send RS from global address to a router. Then I think it would, again, it would work if address is not optimistic, or it would work actually for optimistic addresses if router responds for unicast, because what's happened, all routers would receive RS. If address is not optimistic and MAC address was included into options, then routers will create an entry. If address is optimistic and there is no MAC address SLLA option in RS, then if router responds with array unicast, it will need to do all this neighbor discovery machine. But again, it might introduce additional delay because arrays will be sent with some random delay. They might be throttled and so on. Lorenzo suggested that we might just start pinging the router. Trace, whatever. Some data traffic go into the router address. Trace route, SSH, BGP session, whatever. Yeah, the good thing is it will probably bypass all these intellectual middle boxes on wireless. The cons is I'm not sure you can always send such a packet to a router address. It's additional CPU load on routers, will be dropped by control plane protection. And again, Lorenzo, you will only update the active router, would not work in asymmetric traffic flow. So what I'm trying to summarize is, suggestion is kind of recommend router vendors to do configurable glean from unsolicited NAs. Again, configurable. It shouldn't be on by default. It shouldn't be enabled per interface. And hosts probably can send unsolicited NAs when they get a new address configured. Security considerations. Warren was concerned about breaking stuff. Actually, no, because the only changes proposed is to create entry when entry does not exist. So if you're concerned about host doing ND exertion attack, it could do it anywhere, right? It could send NSs, it could send RSs, whatever. If you have malicious host inside, nothing changes, right? From disruption perspective, again, we're only talking about situation when there is no entry. Even incomplete entry would not be updated. We're only talking about situation when entry does not exist. So it's safe to assume that there is no traffic for that host. Yes, there is a very rare condition when host might be sleeping for 25 days, someone sent a packet from outside, and at the same moment of time, we got a duplicate address coming on. Well, I'm not sure if it's so critical that it better to still see constant packet loss in all other cases. So that's all I have.
Warren, Google, can you go back to the gratuitous ARP one? And while you're doing that, I'll point out that's not actually gratuitous ARP, that's optimistic or gleaning ARP. I think you went past it, or yeah.
That's why it works anyway.
Oh, you want unsolicited NA or you want ARP slide, Warren?
ARP one. ARP one.
It works because you only have one address, and so when you send an ARP request for the router, and so the reason why it doesn't work in IPv6 is that the RA has the SLLAO.
That's not what I was going to say, but all I was going to say is, like, this was a problem in V4. We solved it in V4 by doing the opportunistic or gleaning ARP entries. And that works well enough that, like, on the IETF hotel network, the router doesn't send any ARPs at all. So, like, it's a problem in V4. We fixed it in V4. It's a problem in V6. We should fix it in V6.
Yes, it's not the exact same answer. Yeah. Question. So Lorenzo, have you seen what other implementations do? I think Windows sends or used to send NA to FFO2::1. Have you seen what other implementations do? I know that Android doesn't.
Okay, I have not tested implementations yet. I think macOS does not do that. It was reported on the list from Alexandros that Windows does this. And obviously, I think some vendors implemented that on the router equipment. So I suspect they had a reason for this. So there are some environments when hosts doing this. All right. So, and again, it's kind of, if you want Android device to do this, like to get cache updated fast, it probably makes sense to do something. So as I said, I have some concerns about sending traceroute or pings because it might not work on every environment. And I believe this might better chances to work if router vendors doing Glean.
Have you checked that the unsolicited NA survives like optimizing Wi-Fi devices?
I think I sent one on the device I tested, and I think it did, yeah. Well, it doesn't mean it's going to survive every optimized Wi-Fi, but I assume with what Warren is saying, right, it does for V4. So yeah, we have a good chance. If it doesn't, it might be just this code is not in place yet on wireless devices. But again, it's not fundamental issue.
Jared Mach, Akamai. It seems like, we should update it to be explicit to say that the routers, I think it should probably be promoted from the should text that I saw highlighted to, something else. And I'm sorry.
Right now it should not.
Oh, yeah.
Yeah.
Sorry, I think you might have showed both. I think you might have showed a change.
So basically, it's saying because it currently it's very host centric, right? It's talking about two hosts. So I think what we should be doing, I suggest we write a document for router vendor saying router vendor recommended to ignore this should and have a configuration option to ignore this should and still do Glean.
Yes.
So it's not even we don't even need to update this one, right? Because we're not violating this RFC. It's talking about hosts actually, so it's not a case for routers.
Correct. Yeah, I think we should give explicit guidance to the router vendor implementers, and then do a bit of a few of us should do an inventory of what vendors do stuff, because it looks like iOS does this, but it doesn't look like the others have configuration knobs for this.
Yeah.
Hi, Igor Gashinsky, one of the authors of 6583 with Warren. So the vendor that is doing, so yes, this is a massive problem. The vendor that is doing gleaning based off DAD has done so based on our, I don't know if the feature request would be the right way of mandate. We have tried to actually, when we were writing 6583, this was one of the things we wanted to put in. The equivalent of gratuitous ARP, the way that we were suggesting to do that was basically when DAD is being done, at that point, sorry, not gratuitous, gleaning. Your fault, because you were just mentioning it. But basically do Glean based on receiving a DAD. At that point, put it on stale, revalidate, and kick off the process. We were told that a document of V6OPS should not mention a implementation of a protocol, which is why it was not included in 6583. Yes, that is exactly what we're told. We could probably find some of the original text if you want to do that. Yes, we were not allowed to make, which is why.
Our charter doesn't allow us to write protocols.
It's unclear if that's ready.
Yeah, so we actually had to go to 6-man. There were other there were other changes to.
Responsible AD just said something.
So glorious.
Yeah. So basically, we had other things that we went to 6-man and modified the nut behavior. But this particular one that we tried to modify, we were told wasn't our place. Please finish our work. And I could probably find some of the original text. I probably have it somewhere because I wrote most of the original. I wrote the original thing that Warren had to rewrite completely for 6583. But my original one probably has the Glean text in it. I'll shoot it to you. But the reason why a version of Cisco implements it is because they were our vendor at the time, and we work with them to make it happen, because otherwise my iPhone could take out a data center, and that was not a happy place to be.
Okay, so we discussed the implementation details. Cool.
And the problem is that we were not allowed, as V6OPS, we're not allowed to discuss these implementation details. In here, it was supposed to be 6-man, and 6-man didn't care about the implementation of how it's actually done on routers. They cared about spec. We have this wishy-washy place that it would be awesome if we got fixed.
What we are not allowed to do is write a protocol. We are allowed to, according to our charter, provide operational workarounds. And we are allowed to provide advice to other working groups, and specifically 6-man. Seems like where you're going is we need an erratum against 4861 that says, please do this.
No, actually, so this says should, right?
So you want to change that should in the event that it's a router?
No, I don't think we need to change it. We need to say guidelines for router implementers that they may do the glean, because I assume should. We can violate the should if you have a reason.
That's a change. The word may is actually different than should. Okay.
We should make a change.
Yeah, should not basically mean may.
And so what I'm suggesting is, number one, we need to file an erratum against 4861 that covers the case that you're bringing up.
Not necessarily.
And the other thing that we need to do is provide operational guidance, I think, which is what
right.
No, it's just Warren is chomping.
I mean, so you can file an errata, but there's no way I can accept it because that would be changing what the intent was when they wrote it. So whether or not I agree it's a stupid thing when it was written, an errata can't be used to change an existing document.
So
It can only clarify or like
this
typos.
is really the only way we can fix this.
Yeah, I mean, what we could probably do is if it were to be written in V6OPS and we walked over to 6-man and like, is it okay with you all if we just mess with this bit? They might say, yeah, it's more trouble for us to do it than for you to do it, whatever. But I think it's useful if a document is written. And if we discuss it here, and if we say, we think this is a great idea, and we take it to 6-man, even if they want to actually progress it, having a bunch of operator people show up and say, yeah, this is broken. It would be better if we just make this one small patch. If it progresses here, if it has to progress there.
Then I don't think we need to discuss charter politics further, and we'll do that.
David Lampeter. Let's go from easy to hard. If you have a smart Wi-Fi solution, ideally you would update your smart Wi-Fi solution and it would do the NA to the router for the Wi-Fi client, which is that's totally what's going to happen, even if you don't want it.
Yeah.
It will happen if we proceed this way.
I mean, why would?
So the Wi-Fi controller will interfere. It is its job to interfere basically with all of the neighbor discovery traffic. So it will totally sit its proxy in the middle there.
No, good. Okay, if Wi-Fi controller going to send unsolicited NA and make sure router is updated, fine. We discussed about that routers normally, unless it's one particular vendor ignores those NAs, right?
Yes.
Yeah.
Okay. So either way, that's a detail on the implementation in the end. I do see one privacy issue with this, which is that if you do the NA for a privacy address, you have to broadcast it essentially, or multicast it. So you didn't do that before.
You sent an NS for that. You do that.
But
yeah.
Okay. Well, the hashed.
Yeah.
We've got 5 more minutes.
Okay. We have 2 more people on the line.
Eric Klein. I'm not an AD, but it seems like a document that's saying why the should is violatable for routers. It's not necessarily out of scope. That's all you need to say, right? Just explanation why and how to fix. Also, in any of the testing that you did you ever try setting the router alert option on any of the messages? And does that change anything?
No, can we try it in your office and just in case? Yeah, we can, yeah.
I don't know how routers actually behave with the router alert option. Maybe they all ignore it. But if you did,
Eric, write me a code running in your office if I'm not get paged for router crashing.
also, I mean, testing with Android devices, those addresses are optimistic by default, right?
So
they'll
I have
never
not,
have
Eric, I have not tested that
SLAO
stuff.
option, so you'll need to try it with something that's not an optimistic mode. Tim Winters, UNHIOL, couple things. I think this is a good idea. I do think we're going to have to put something in here about it being an update to 4861. There's way too many implementations out there that will just ignore these packets. The only other thing is make sure it goes to the all routers, not to the all nodes address, because we only want routers to care about this. And
I think I forgot to put it in the text, but I was thinking you can send NA to all routers.
Yeah. Okay. And what was my third thing? I can't remember now. Oh, we have plenty of implementations, and we'd be more than happy to tell you guys what current implementations do at the IOL. So.
Offering to be a co-author? That'd be awesome.
Whatever you guys need.
Lorenzo Colletti, speaking of all routers versus all hosts, I know that there are a bunch of devices that drop stuff to all nodes, but not to all routers. And if those things happen to have forwarding turned on, then by sending it to all routers, you'll start chewing up their batteries. We want to be careful about what current implementations do. Sorry about that.
David Lampeter again. But if you don't send it to all routers and you don't send it to that group, but that's exactly where I don't want it for privacy purposes, because it's not on all nodes yet. If you have a privacy address, you're at least a little bit private still.
Can be a little bit private. Is it private or not?
So this is actually the exact reason for why originally we were proposing to glean off of that. Because anybody that cares about that could, aka routers, could essentially,
AKA your privacy snooper.
which has to be anyways.
Yeah, so
Like anybody that's listening to all that is listening to all addresses.
Okay, so then quick question, can we call for adoption? Or do you think more work required? So...
Well, we'll actually do the adoption call on the list. But let me ask for a sense of the room. Do you think this is something that we should adopt? If so, if not,
Thanks.
Okay. So, okay, Eric.
Which one is it?
That one.
Okay, thank you. And if somebody's in the Jabber room, that could be interesting if somebody replace me when I'm speaking here. I am single entity of myself. I'm no duplicates. Okay, anyway, this draft is basically belonging to OPSEC, where the two chairs are here. So thank you for being here and supporting me. For authors, and basically it's, as you can read, we try to analyze all the operational security issue in several places in the network. Specific focus on service provider network, enterprise network, and residential. As IoT is a very complex place, we do not talk about it, even if some couple of things we say in this document also applies to IoT, obviously. And that's an informational draft. And what we want to do is basically, I mean, all of us are doing V6 deployment. How often do you get how secure is it? How can I securely deploy my network? So we try to put all things together there and our recommendation. So now the bad news. We are working on this since September 2012. I was not even the OPSEC chair at that point of time. You were not even, right? So a long, long time ago, but still in the 21st century. And basically, it's quite a vast domain. And it's a kind of a moving target, right? We have a couple of people in this community discovering new security issue. And so we need to update the draft and so on and so on. As I said, informational document, it's quite long though, 50 pages. Another thing, we are putting the record on how many reference we have in our reference section. I counted them yesterday, 116. Because basically the text says, hey, for this, we briefly explain the issue, and then we refer basically to the RFC or the other documents that are not always IETF documents, by the way. It's consideration. It's not recommendation, by the way. So the structure of the document, the big part is about generic security consideration. And I shall come back on this on the next slide. Then we go couple of pages on enterprise, I said, couple of pages on service provider, where we talk about BGP, about the transition mechanism, including the translation mechanism, of course, and LI, right? I mean, the service provider network. And a residential network, we simply refer to those two RFC here. The big chunk, so, is generic consideration. And then we go, and the first paragraph was addressing architecture, and at the beginning we were doing a lot about ULA. Now it's only one line, basically, because there's quite controversy there. We talk about DHCP, Slack, privacy consideration. Next step is about extension headers, orders, hop by hop, what we do with fragmentation, and refer to your draft. Link layer security, what about neighbor discovery, of course, what about rogue array, and so on. A few words about 3GPP as well. Control plane security, it's easier because it's mostly the same in IPv4 and IPv6, so that's easy. The only exception is what we call the packet exception. This is when we need basically to send the packet to the CPU, okay, which are sometimes different compared v4 and v6. Routing security, basically explaining what we can do there about the routing updates, the route filtering, refer to this RFC 6066 about the discard prefix, for instance. Everything about the transition techniques, dual stack, encapsulation, translation. We even kept Teredos and 624, even if nobody is using it, because when we talk to customers and people deploying it, the questions still pop up. And it's clearly indicated those two has been made historic, and generic device hardening. Where we are, so we are revision 17, I think, or whatever. Obviously, as I said, some sections were quite controversial. And, right, I mean, I see at least somebody in the room here, another lady in the end, and Tim Shawn is not here, but many people has provided feedback. Okay, and we listen to this, right? So we basically now pointing the text ULA, nothing. We don't talk about PI versus PA, for instance. We try to take into account all the consideration that were raised on the mailing list in a previous review in this group a couple of years ago. So we think we are now in a reasonable shape here. Couple of acknowledgement, and I think many people in this room are part there. That's all the people sending review comments. Thank you again. We have requested working group last call to Jen and Ron, so the OPSEC working group chair. They want to talk to me, I guess, before doing this, so we'll do it later this week. But as an author, I would love to get as well, we will go to, if everything is okay, working group last call in OPSEC. But in this case, it's also V6. So while we do the working group last call in OPSEC, it would be nice for the authors that you also do the review here, okay? Because that's OPS after all, and V6. So I hope that we'll get some people reviewing it. I understand it's 50 pages, so it takes some time, but it's really useful because after reading it, I mean, the authors we don't know anymore, right? Okay, so basically we hope to get this done. Thank you again. And any questions? Natalie's.
Hello, Natalie Tredeman, RIPE NCC. Every IETF that there is a presentation about this draft, I go to the mic, I thank the authors, maybe one or two comments.
No.
This is done. I'm done.
Okay.
I read it again after the last revision. It looks great. Thank you. I would suggest indeed last call and move on, and maybe after 8 years to be done. Thanks.
Thank you, Natalie.
Jordi Palet.
Oh, I'm scared now.
Jordi Palet. I don't know if you have seen my last email a couple of days ago. I think basically it's done. I read all the text again after the IETF in March and again last week. There are just a couple of needs, and I still disagree with not differentiating between MAP-T and MAP-E because they are somehow different from the perspective of security. And then I think the other comment was there is nothing about the DNS proxy problem if you don't have a DNS proxy in the CPEs. If you need clarification, we can talk about this by email. I think it's simple to add some text on that.
Okay, anyway, thank you for your email. We have no time yet to react on it. And I don't understand indeed your DNS proxy, so we need to talk. Lorenzo.
Yeah, I mean, I think your strategy of trying to change nothing is good. If anyone reports anything with any text, delete the text to say, okay, it's out of scope. One thing you do need to delete is the reference to the ULA usage considerations document, because that ain't happening.
Yeah,
That's also been open for years. So it's all because like until that gets out of whatever, until that makes it to RFC, you can't publish this one anyway, right?
Yeah,
So,
correct.
Yeah.
Correct. I was wondering the same thing, Lorenzo, to be honest.
In my March review, I provided a text about the ULA that I think it will be better than deleting that. You may want to reconsider that text. Please read it again.
I usually don't want to touch ULA, right? From a but specifically on this one.
I think the text you have. I think the text you have there for ULAs is fine as long as you delete the reference to the thing that's not going to get published.
Okay, thank you.
Okay.
Oh, maybe we can reach it.
So, question. Are you looking for comments to come to V6OPS or to go to OPSEC?
I think if you can put OPSEC, I mean, it's up to the chair, by the way, here. I would love this community to review it and send a comment to OPSEC, right? I mean, all of us are in the same thing, so we will see it anyway. But put the name of the draft there, right? That's the way when the mailing list, when you look in the archive is.
Okay. Can I get 2 people to volunteer to do that review? Okay. So Jordy.
And Natalie.
Okay. Oh, okay. I can't see through the poll. So.
And anybody else interested?
Yeah.
Yeah.
Okay, go for it.
Okay. Thank you.
Yeah. Okay. Thank you. Okay. And now I'm being a little bit amazed because we actually have 20 minutes left. So I'm gonna, going back to the agenda, we have a couple of AOV things, 3 AOV things, and I'm gonna let Uma come up and talk. Okay, so yeah, so the one in your right.
Sure.
So Uma's got 10 minutes.
Sure. Okay, my name is Uma. I'm going to talk about ISIS V6MT deployment considerations, and I thank chairs for kindly agreeing to put this because they asked me to send an email. I could not send. I was traveling, but I promise after this meeting I will send an email with a document and on my comments. If you have anything I want to ask, I will send it. So this is regarding the ISIS protocol for V6 only topology or multi-topology. Okay, this work has been presented in LSR working group in IETF 103 based on the feedback and suggestions we are presenting in V6 operations. Some of the people said that, this is no document is required. We don't want to do LSR working group, doesn't want to do deployment considerations document. Some of the things are known and, that kind of stuff. So I just wanted to know your feedback. If this is a known thing, that's fine. Otherwise, we want to think, we think that it's good to document what is there out there. We are not changing anything in the protocol. So background, there are a lot of IPv4 ISIS deployments. Few more folks are seeking IPv6 only deployments. The first thing I worked in 2012 with my old employer, we started looking at IPv6 only deployments. Still, it's happening. The questions are the same. We are amazed, but but this is the fact. So this is based on talks with multiple operators. Most of the things we are looking at it is right now mobile backhaul, where for 5G services are being deployed. People are thinking about IPv6 only. Some people are looking for SRv6, and folks are in L3 DC underlays looking for V6 only deployments. So what's the goal and what can be done? Goal of this document is to lay out the nuances around ISIS and IPv6. There are a lot of options with ISIS. How one can deploy with IPv6. The first thing I wanted to clarify is ISIS multi-topology is not equal to IPv6. It's one way of deploying IPv6. The second thing is provide various options and limitations with ISIS for transitioning to IPv4 to IPv6 and looking for IPv6 only deployments. So it doesn't provide, this document doesn't provide any protocol extensions. It's only, it's what is there over the last 10, 15 years, what happened in ISIS protocol. It's just a documentation of what the nuances. Non-goal, there is ISIS multi-topology. There are a lot of use cases. Even the developers, even the people who are writing the drafts get confused what MT can do and what cannot do. There can be a lot of things that can be done with MT, but we are not going to MT what can be done and the exhaustive use cases around MT. Okay, IPv6 in ISIS. Primarily, there are two ways to do IPv6 in ISIS. One is IPv6 first introduced in 5308, RFC 5308. There is a new reachability TLV, TLV 236. It works on a single topology mode. That means one decision process happens. That is one SPF happens, and you get to compute both IPv4 routes and IPv6 routes and download to the FIB. So there is that's the one thing. There is a limitation. There is a condition there how this works. I'll come to that later. Later on, RFC 5120 introduces ISIS multi-topology. This brings to topology-specific adjacencies and topology-specific decision process. There is TLV 22 added for adjacency TLV and TLV 235, 237 added for multi-topology TLV, where reachability IPv6 addresses can be advertised. So as I said, topology decision process, topology-specific decision process, that is every multi-topology you have ISPF computation happens. And the main thing is here, MTID2 is reserved for IPv6 routing topology. And this is where most of the ISS-MT deployments are seen. Basically, ISS-MT is used only for MTID2. It's a safe alternative to deploy IPv6 in the legacy networks. So what's the problem with RFC 5308? Only thing is it's very simple. IPv6, just one TLV 236, you're good to go. But the only condition is the whole network should be congruent. That means all the nodes and links have both V4 and V6 should be enabled. For one simple example here, let's say a network like this. Everything is V4 and V6, but between RX and R2, only V4 is enabled. What happens is, in this case, in the RFC 5308 is a single topology mode. Even though there is an alternate path between RX, R1, RY, R2, but the shortest path is between RX and R2. So it tries to get this, and you'll get a black hole. So basically, your routing gets black hole here. So that's the problem. So basically, for RFC 5308 single topology mode to work, all the links and nodes should have V4 and V6. So how this gets fixed? Either you can enable V6 on that link, or you can switch to RFC 5120 where you can do MTID2, because decision process is different there. So you don't have to worry about anything there. So there is a single topology mode with multiple address families. So we talked about this restrictions. Network must be congruent. We have seen this. And some examples where this is not possible, when IPv6 is getting introduced in the networks and legacy nodes does not support IPv6, or implementation issues causing IPv6 to be disabled, or hardware scale limitations causing IPv6 to be disabled on low-end devices. So all these cases forced people to think to ISS-MT. But still people are using this, and we get questions even after 8 years of my first question. I got it from 2011, and still I get these questions actually. That's the reason we wrote this document. So a note on ISS-MT. Here, single adjacency with multiple MTIDs. In the adjacency, you list all the MTIDs you support, and MTID specific decision process is done, and the common RIB and FIB. But the thing is, MTID deployments only MTID 2 is only seen because a lot of implementations, a lot of the big vendors don't support other topologies in MT. That's one of the problems with MT. Okay, so another confusion with ISS is all around the terminology. Now we can see that multi-topology, it says that MTID2 is reserved for IPv6 routing topology, but rather they should have said that is address family. There is no distinction between address family and topology there. It's all mixed up there with the terminology. This caused a lot of confusion. Even a lot of questions comes because of this fact. So yes, MT can be used for other than IPv6 routing topology. If you MTID4, you can do whatever you want, another IPv6 routing topology. Maybe they wanted to say that this is the first routing topology with IPv6. It's a tiring conversation. If you want IPv6 only, use MTID2. I don't want multi-topology. I just want single topology, IPv6 only I want, but still you have to use MTID2 because that's reserved IPv6 routing topology. Okay, one of the goal of this document to use this conversation. Another deployment note is, as I said, a lot of big vendors don't support multiple topologies generously. There are the other ways to do this. If you have interest, I can talk to you guys, but this is the fact. So in summary, this document only provides various options available for IPv6 only deployment or transition to IPv4 to V6, and what are the pitfalls to avoid. Maybe this is known to a lot of people, but this is not the thing that I got when we're talking to customers. And it demystifies what's been out there in ISSMT. And any comments, feedback, I'll happy to take. And we are looking to ask for adoption in LSR working group.
Ask for adoption where?
LSR working group?
LSR.
Sorry, yeah. So one of the LSR feedback I got was ISIS IPv6 all done in 1195, RFC 1195, and they don't want to do deployment guides because it's a known issue. It's so many things there tied up there. Even I didn't put multi-topology transition. There is another confusion there. So all these are documented in. I thought it will be useful, but it's up to the folks here. Also, I'll get the feedback from here.
Okay, so I'll ask you the same question I asked Eric. Where do you want the feedback to go?
I want feedback from here, V6 operations, because these are the folks who are deploying IPv6 only network or transitioning to IPv4 to V6. So you guys might have faced some of these problems, or you might have workarounds, and
You want us to post the comments to LSR?
No, V6. I will send a mail to the V6OPS, and if you can send the feedback in the V6.
Well, you want the response on V6OPS?
V6, yes. That will be useful. And that will be useful for me to say that I presented this in V6OPS, and this is the feedback I got.
Okay.
Okay, so 2 questions. One, please make comments, whatever comments you might have, put them on the V6OPS list, and we'll summarize them forward. Does anybody wish to do an actual review of the document? I don't see that, so you will. Okay, so we'll get one review, and we'll summarize any comments we got. So.
Thank you so much.
Okay.
Thank you, guys.
So with that, Jordy. You have
10 minutes?
12 minutes.
12 minutes.
And 2 drafts.
Yeah.
What do you want to do? Pick one.
I can go to that one very quickly just to get comments in the list, hopefully. Okay, so I started this work something like 10 years ago, but at that time we didn't jump into it actually. The main point is that when you read the document about how you do point-to-point links, it looks like it's recommending /127, but actually this is not what the document says. What the document says is that routers must support it. So I am trying to clarify that here, especially because almost 70% of the networks are using a different way. So we should document in V6OPS what is actually being used in the networks, right? There is also another point here, which is supported by RFC 6603, which is the exclude option for a /64 from a bigger prefix. So if you have, well, actually a shorter prefix. If you have, for example, a /48 for a customer, you can use the first /64 for the point-to-point link. And this is not documented anywhere. It's referenced as something that can be done because you have the exclude option in the HCPv6 prefix delegation, but it's actually not documented. And a lot of people is using that. So what I am trying to do in the draft is describing the different choices that you have for the point-to-point link, good things and bad things from each one, and also the numbering ways. So for example, you can use global unicast, you can use ULAs, you can use unnumbered, which is a link local, and so on. So that's basically what the draft is describing. All those are used by different ISPs, but we don't have a real document which is describing all the choices. Okay, so most of the time when you get questions from ISPs, how I do that? You don't have a single document to reference everything like that, and some of the possibilities are not documented in any way. So that's basically it. I got some comments from Eric 1 week ago. It's true that the draft was dormant for 1 year because I didn't have time to update it, but I plan to have a new update in 1 or 2 weeks, taking in consideration Eric comments and if there are other comments as well.
David Lamputter. So you're missing at least one option, which is to assign a 64 to a router and assign 128 out of that 64 to links.
Oh, yeah, that's another one. Yeah, thank you. I will consider that. Please send something to the list. Okay? Thank you. So done?
Okay, so
So, again, same with this document. It has been dormant for 1 year more or less. I didn't have sufficient time to take over it, and at that time it was not considered by the working group. But this is a discussion that we have every 2-3 months. Actually, I think 2 weeks ago we had the same discussion in the list. So in other working groups, we have definitions of terminology. We don't have that here. And this is a very simple definition about what is native, what is IPv6 only, and that's the goal of the document. So let's try to speak the same language because we are confusing people. That's it. I don't think I need to go through the slides. It's so simple like that. You may agree or not with this definition. That's the reason we need to work on that. Okay? And that's it. Thank you. Go to the list, please.
okay, thank you, Jordan.
I made it in time.
Everybody sign the blue sheet?
Where are the blue sheets, by the way? Okay, so I need one up here. No. With that, I guess we're adjourned. Right?
Sorry, I was looking. Andrew, good to finally meet you face to face. What are you doing 9 o'clock tomorrow?
Absolutely nothing. That sounds good. I want to. We need to figure out what the final decision is on